Welcome back. Yeah, so just jumping straight into the lesson today. So last week we talked about recursive methods and started talking about classes in Java. And so I have the review questions, as always. So first I have two questions that I want you guys to try to answer about recursive methods. So the first one was last week, last week on Friday, I said that recursive methods generally have two parts to them. Does anyone remember the names of those parts or um, what I meant by that? How about Sophia? Do you remember the two parts I was talking about last week with recursive methods? Um, okay, I'll just go over this one for you guys. So the two parts of a recursive method are called the base case and then the recursive call. So generally, um, it makes a little bit more sense to think about the recursive call first. That's what makes a method recursive, right? The idea that the method calls itself. So the recursive call, generally what it does is it takes a step towards a smaller problem, a simpler problem. So with the Fibonacci example that we looked at last week, to calculate like the 10th Fibonacci number, you break it down, right? You break it down into calculating the 9th and the 8th Fibonacci numbers and add them together. So that's the recursive call, taking one step down, making it simpler and simpler. And then that's where the base case comes in. The base case is basically saying that's your like fundamental level. You can't make it any simpler. Generally, the base case is like you know the answer. So Fibonacci, you know that the first two Fibonacci numbers are 1 and 1, at least in our case. So that's going to be our base case. You don't need to take any more steps. You've reached the bottom and you can stop. Yeah, sorry, I just saw your message, Sophia, but that's exactly right. That's the base case. The base case is like the stopping point for your recursive method. Um, and that leads us right into the second review question. If you don't have a base case, or if your base case is written improperly, sometimes you're going to have a recursive method that never ends. It will just keep calling itself forever and forever. And does anyone remember just the name of that error? Uh, what happens if you run that in your editor? You're going to get some red text. What is it called?
Overflow?
Yeah, Stack Overflow is the full error name. That again, that just means essentially you've run out of memory for your program because every time you call a method, it takes up memory, it takes up space, and if you just keep calling it forever, you're just gonna take up all your memory and you're not gonna have any space left for anything else. And so that's also why it's an error and not an exception, because a while back we talked about errors and exceptions. Errors are generally more severe. You can't recover from errors. Um, so like you can't really solve a Stack Overflow with a try catch because like the problem is you've run out of memory. There's not much you can print out some messages, but there's not much more you can do to recover from that point. Um, so okay, before we go on to the next review question, because that's going into classes, I'd like to take a little bit of time to go over the homework from last class. And so that was like calculating the number of handshakes uh, at a party. And so I don't know, Ryan, do you think you could share your homework answer with everyone? Thank you. And so can you just tell everyone like what the base case was and how you figure out the recursive call?
So first I called the method handshakes. Then if n was less than equal to 1, I would return 0. And if it wasn't, I would return n minus 1 and then recursively do handshakes n minus 1.
Yeah, so here the base case is n is less than or equal to 1 because if you have 0 or 1 people at a party, there's no one to shake hands with, so you're going to return 0 handshakes. And then to figure out the formula for the recursive call, um, the best way to think of it is to not think of the code at first. Just think about it how you would solve it yourself. And so the way you can think about it is like, uh, if you want to figure out how many handshakes will happen with, let's say, 4 people at a party, you can think about, well, that's going to be the same as if there were 3 people at a party, but now you have an extra person. And so the 3 that you already took care of, each person has to shake hands with the new one. So whenever you add a person to a solution you already know, basically everyone that already exists has to shake hands with the new one. So the number of handshakes for 6 people is the same as the number of handshakes for 5 people, but then those 5 people have to shake hands with the additional 6 person. So when you think about that in code, handshakes n is going to be equal to handshakes n minus 1, so like one step down, plus n minus 1. Because for handshakes 4, it's going to be the same as handshakes 3 plus 3. Right? So that's how you can think about to tackle this problem. And recursive methods are definitely a little bit of a challenge at first. It definitely takes some practice to develop a good like set of instincts to figure out what is the base case, how should I do the recursive call. And if you guys would like more practice, there's a really good website called CodingBat with a bunch of questions, not just recursion, but I'd highly recommend you guys just try it out. I can put a link in the chat as well. Um, but that's just a source where you can get a couple more practice. And so thank you, Ryan, for sharing your homework answer. And we're going to get back to the review questions. So for now, we're done talking about recursive methods, and we're moving on to continuing talking about classes. And so at the end of last class on Friday, I mentioned a specific method with a special name involving classes, and that's the method that you use to create an instance of the class. So we first saw this when we were learning about methods and how to call methods, right? You had to create an instance of the class to call the methods. So yesterday or on Friday, I told you guys the special name for that method or that family of methods. Does anyone remember that name? And just as an example, you can see in the slide, it's going to be this method in blue because this is the method that you use when you're creating an instance of the class. And so as a hint, the name of it starts with a C. Okay. I'll just give the answer for this one because it's kind of just memorizing, and I know I went over it very quickly last class. But the name of this is called the constructor. So the constructor is the method that you use to create an instance of the class. So if you remember from last week, a class is kind of like a blueprint. It tells you what this thing has, what information it knows, what methods it can do. And so on the screen, you can see an example of a phone class. So here, this phone has some data. These are called fields. Has a model year, brand, and then also has this constructor. And so this is what you use to create an actual instance of a class. So the class is phone, but the instance is a specific phone, like maybe the phone that you own, right? That's an instance, but the class itself is just describing everything that a phone does and has. And so we're actually gonna look at this code a little bit more. So I'll paste this again in the chat. Maybe you had this from Friday as well, but I think I also have it on my editor. Let's see. No, it's class phone right here. So I have the code here, and this is all that was shown here. And so the exercise that the slides want you to do is to create another instance of the class. So in this snippet that I put in the chat that was on the slides, we created the first line of the main method. It says phone my phone equals new phone. And then we use the constructor. Here it takes in a number, an int, and a string for the name. And so we gave it the year 2009 and the name Apple, the brand name. And so now that was creating one instance of the phone class, but you can create as many instances as you want. And so this was just showing that you can create another phone object using the constructor again. So I'm just going to copy that line, paste it, and maybe we'll have to give it a different name. So like maybe I'm just going to call it phone2. And maybe the year I'm going to put as 2010 now, and the name Samsung, right? So now we have another instance of the phone class here. And then what I can do to show you guys, we can access the year and the brand of the other instance as well. And you can see that the two instances, my phone and phone2, have their own copies of these fields right here. So every time you create a phone instance, you get a copy of these variables, these fields. And so they aren't like overridden, right? So like when we create the second phone, it doesn't change the brand or the model year of the first one. And so I can just show it here. I have to another line. But if I run the main method here, what it's going to do is going to create two phone instances and then print out the year and brand of each phone. And so you can see one of them is Apple, built in 2009, and the other is Samsung, built in 2010. And what you can see is each instance has their own copy of the fields. And that's important to remember. But there's some things that I want you guys to try, if you can, on your own editor. So the first thing is to change one of the fields to static. So static we talked about with methods before. Static means it belongs to the class itself and not an instance of the class. And so that might give you a hint of what happens, but I want you guys to just write static here. And can you tell me what you think is going to change in the output? Or just run it, see what happens, and then if you could tell me, or if you'd like to share your screen. but I can tell you the 2 lines that we have here is going to change a little bit. Okay, well, I'm gonna run it on my screen. So what you should have seen is that before, when we printed out the model year and the model brand, it was different for each phone, right? Because here we create my phone has year 2009 and the name Apple. And then phone 2 has the year 2010 and Samsung. Okay, so Christina, could you just tell me what changed and maybe why you think that might have changed? Like the reason for the change? Yeah. So when we added static to this field, the model year for both phones when we go to print it out is going to end up being the same. And so the reason for this is because of what the static keyword means. It means it belongs to the class and not to an instance. So when we add this static keyword up here, it means that this field, the model year, no longer belongs to a specific phone. So now when we create the my phone and phone 2 instances, they don't have a copy of the model year field anymore because it doesn't belong to an instance. It belongs to the class as a whole. And so when we create another phone and give it a different year, it sets the model year variable to whatever we give it. But then when we go to print it out, when we access this variable, each instance accesses the same thing now. They don't have their own copies. They class has a single one, and every instance uses that. And so this was like um, kind of a tangent, but when I started programming, uh, I had a bug that th- this was the reason for the bug. So I was like programming a simple game with like enemies that moved around across the screen, and I had like 5 different enemies that I created instances. But then I was like, why is it only showing one of them on the screen? And that's because when I created my class to describe what an enemy is, I created the X and Y positions as static fields. And so what happened is whenever I created a new instance of the enemy object, it changed all the previous instances to have the same X, Y values because it's static. Each one doesn't have their own copy anymore. There's only one for the whole class. And so that ended up causing a lot of headaches. And then when I figured it out, it really taught me the difference between like a static field and a non-static field. Um, and so the second thing I'd like you guys to try, and so we changed the model year a little bit. For the brand, what I'd like you to try is to add the private keyword. So if you remember, private kind of affects the visibility of things. So for methods, it affects who can call the method. And for fields or variables, it affects who can access the variables as well, the values. And so if we add private here, and make this a private variable, and we run this, it shouldn't have a problem here. But what can happen is if I take this code and so I have another file. This one is called class lesson. it's in the same folder as the phone class. And so I can access the phone class code. So I can create a phone class here as well. So like I can just copy this main method into a separate file, separate Java class. And now, before I even run, you can see there's some red text. And it's saying brand has private access in class.phone. And so what this is saying is I'm running this code in a different class now. This one's the class lesson class, right? This is no longer the phone class. And so this private keyword is saying that you can only access this variable if you're running code within the phone class, right? If you're not in the phone class, you don't have access. And so that's why when I try to access these variables in a different file, I'm not allowed. I don't have permission to. These are private variables. If I remove the private, then the red text goes away and everything is fine. I can run it and there's no complaints. And so that's some things you have to remember. Static versus non-static, private versus nothing or public. Basically, those are just modifiers to who has access to these variables, and also like how many copies are there? Like, does each one have their own copy, or is there only a single copy for the whole class that everyone shares? So moving on to classes. We talked about method overloading. Does anyone remember what method overloading meant? You had a homework assignment where you overloaded a method. Amazon, do you remember what method overloading meant?
It's like where two or more methods have the same name. So,
Yeah.
yeah.
So it's when multiple methods have the same name, but they can't have everything be the same, because then you'd have duplicate method signatures, and that's not allowed. So it's the same name, but different parameter lists. And so the constructor that we talked about is just like any other method. You can overload the constructor as well. And so what that does is it gives you multiple ways of creating an instance of the class. And so that's what we're looking at here. For example, if in the phone class, I can make some changes. So this is the phone class, the code that you saw before. I can write another constructor method. So I will copy everything except for the parameter list. So public, then phone. And then the parameter list, maybe I'm only going to take in a year now. So int year. And then I don't take in a string for the name. I just have open curly brace, close curly brace, and then I have whatever code inside. So maybe here, I only set the model year to the year. So what I give it in. And maybe I can give like a default value for the brand, right? So brand equals unknown, right? So now I have two constructors, right? I have this constructor that takes in a year and a name, and I have this constructor that only takes in a year. And now I can use either one that I want to create an instance of the phone. So before we used the one that took in a year and a name, but now I can create a third phone. So phone3 equals new phone. And now instead of giving it two things, I can just give it a year. So let's 2019, or yeah. And semicolon, and you can see everything's fine, no errors. And then I'm going to change these back. I'm going to remove static because it doesn't make sense for that to be static. Now I can print out the year and the brand for phone 3. And you should see that the year is whatever we gave it, 2019. And the brand is this unknown, like kind of default value. So if I run phone, yeah, you can see now I have a third line that prints out. The year is what we supplied and the brand is unknown. So this just shows you can overload the constructor. The constructor is nothing special really. Think of it as any other method that has parameters and output. Yeah. There's also something that relevant that goes into. If you don't write a constructor, Java automatically creates one for you. So it always gives you a constructor, whether or not you write one yourself. And if you don't write a constructor method, it will automatically give you a no argument constructor. So no parameters, doesn't take in anything. So if we go back to the fun class, this is the one that we've been using as an example. I can comment out the two constructors that we already have. And now these lines are kind of have problems, but now what I can do is I can say phone, my phone equals new phone with no parameters, right? And this line compiles, right? Even though we didn't write a constructor ourselves, we can still create a phone object. And this is what you did when we started learning about methods, because you guys didn't write a constructor for your class. You just used the default constructor that is automatically generated if you don't supply one. And so the question is like, well, if this is automatically written for us, what does this do, right? Like, what does it automatically do for you? And all it does is call the parent no argument constructor as well. So we're going to talk a little bit more about parent classes, superclasses more in depth later. But again, parent classes is like kind of one level up. And so in Java, everything, if you go all the way up, you get to the object class. And if you don't specify a specific parent, so like when we were creating this phone class, we didn't say we want the parent to be a X class. By default then, the parent is the object class. And so this no argument constructor for the phone class just calls the no argument constructor for the object class because it's the parent. And so this can cause an error as well because maybe there isn't a zero argument constructor for the direct parent. And that's just something you have to like watch out for. You probably won't run into this very often right now because when you design classes, it's probably going to be pretty simple and not many layers to each other. But you can easily imagine that like in these Java libraries that you're working with, right? Like you have java.lang.whatever.whatever. Like these are kind of just nested things and you have these like huge directories and it gets really complicated sometimes. So it's more of a thing to watch out for when you're writing multiple classes that all like have a parent and then a grandparent and then a grandparent, things like that you have to watch out for. And so this is what it looks like. Like this is the code that is generated essentially. It just creates a no argument constructor and the body calls this thing called super. And super is this special method that just calls the super class's constructor method. That's what super means. This is just talking about how if the superclass doesn't have a no argument constructor, it's going to cause a compilation error and it's not going to run. So we're done talking about constructors, and we're going to talk a little bit more about class structuring, like how do you organize different classes together. One way you can do that is having nested classes. Like just like you can have nested loops where you write one loop instead of another loop, you can write one class inside of another class. And there are two types of nested classes, one for static classes and one for non-static classes. So the static keyword keeps popping up again and again, and it can describe classes as well. So you can have a nested class that's static, and you can have a nested class that's not static. Static nested classes are, well, here, non-static nested classes, so if you don't have the static keyword, are called inner classes. And that's just a term that you have to remember. This is not as important, I would say, but one thing we have to talk about is visibility again, the public, private, protected, or default, which default means package private. And so the outer class, whatever, when we're talking about nested classes, we have the outer one and we have the inner one. The outer class can only be public or package private, which is default. So if we look at the phone class, we say public class, but you can also have just class. You can have, but you can't have private class, there's red, and you can't have protected class, and it's red. And the reason why you can't have private or protected is it ends up private, if you have a private outer class, it ends up that no one can access your code, right? Like it's kind of pointless to have private classes, outer classes. And for protected, it ends up being that protected visibility is the same as default visibility. So it doesn't allow you to say protected because it doesn't make sense. It's just the same as default. But the inner class, the one that's being nested, can be any of the four that we've already talked about: public, private, protected, or default. The next couple slides describe what fields and methods are accessible to nested classes. And so the way it works, you can generally sum it up as that inner classes, so non-static nested classes, have access to basically everything. But static nested classes have a little bit more restriction. Yeah, so you can see here, non-static nested classes, aka inner classes, have access to other members, which mean fields or methods, of the enclosing class, the outer one, even if they are declared private. So even if you declare something, a variable, a field, as private, if you have an inner class, it can access it because it's inside. It's within the bounds of the private. Right? You can think of private as like a fence blocking in other people from accessing your stuff. But if you have an inner class, that class resides inside the fence, so it's not being restricted by anything. It can do whatever it wants. However, for static classes, they don't have access to non-static variables. Just like how you can't call non-static methods inside of other static methods. So might have run across main is a static method. This cannot call non-static methods. Static methods can only call other static methods directly. The same applies here. Static inner classes can only access other static things directly. If it wants to access non-static things, it has to do it indirectly by first creating an instance and then using that instance to access whatever it wants. And you have code snippets just to look at here. This is describing an outer class and an inner class. So you can see the first line creates the outer class, and this open curly brace corresponds to this last one. So everything here belongs to the outer class. The outer class has a field x, which is an int, and it's set to 10. Then it has this inner class, which is everything I've highlighted here. All the inner class has is a variable y, right? Then we're outside of the inner class again, and we're actually, My bad. The curly brace, I think this is a little bit, the braces are a little bit messed up, but actually no. So this describes the outer and inner classes. The outer class has X, the inner class has Y. And then you have this other class just for the main method. And what this main method does is it creates an outer class, and then it also creates an instance of the inner class, and it accesses Y. So this is how you would access this Y variable, just with this code here. And then on the next slide, the only difference here is now it's static. And that affects the lines in the main method, how you access this Y variable now. And I won't get into the details. If you're interested, you can look at the slides after I post them. But you just can compare the difference between the main methods. Here it's 3 lines. This one is 2 lines. And yeah. Just some additional rules. Inner classes cannot define static members. It's just a rule. Just you have to memorize it. There's a little bit of logic to it. It's just because static belongs to a class, but like inner classes already belong to a class itself. So it's a little bit weird if you declare static variables inside of inner classes. So it's just not allowed. There are also other types of nested classes. So we only talked about like static and non-static nested classes, but you can also create local classes and anonymous classes. Briefly, local classes just mean it's a class inside of a method. Like you declare a class inside of a method. And anonymous classes are basically just classes that don't have a name. You don't really have to know that, but if you are interested, you can look more into it. This code is not super relevant, so what I'm going to talk about now is abstract classes. And so I'm gonna just really pause because I know I'm just lecturing for a bit now. Do you guys want me to go over this code for you guys to like understand nested classes a little bit more? I would say nested classes they're good to know about, but aren't as important as the things that we talked about earlier with constructors. Constructors, you definitely need to know very well. Nested classes is kind of just a little bit more special. Sometimes you want it to organize your code a little bit better, but it's never like necessary in any case. So like, I just want to make sure no one has any questions moving on because if you're confused now, it's going to be a little bit harder to follow along as we continue. Okay, I'm going to move on for now. As always, if you have any questions that you don't have answered now, I'm also available after class and through email or classroom whenever. So please don't hesitate if you're confused or don't understand what's going on. Please don't hesitate to reach out to me. I'm very, very happy to help. So what we're going to talk about now is abstract classes. And so first of all, I'm just going to talk a little bit about what abstract means. And so like you might have heard like abstract art or I don't know where abstract is used a lot in a normal language, but abstract usually means like it's kind of more of an idea. It's not like an actual thing. It's not concrete, right? It's not a thing that you can hold in your hands. It's more of an idea. And so that's what abstract means in coding as well. And so abstract itself is a keyword. It's used to describe classes, used to describe methods. just like how private is used to describe methods or static is used to describe methods. Abstract is just another keyword. When abstract is used to describe classes, what that means is that that class can no longer be instantiated. You can't create an instance of an abstract class. Well, technically there are ways around it, but in general, that's what it means. So if we look at the code, and as always, looking at the phone class, I'm gonna put it a little bit back to normal. If we now say public abstract class phone, now what happens is I get this red line when I try to call the constructor. It says phone is abstract, cannot be instantiated. And so that's the core of what abstract means when it refers to classes. If you have an abstract class, you can no longer create an instance of it. That's the thing they have to remember. The opposite of abstract class is a concrete class. So if it doesn't have the abstract keyword, it's called a concrete class. And so you might think about like, well, if abstract makes it so I can't create an instance of an object, like what's the point of it, right? Like it just restricts me and like it seems kind of useless. If I can't create an instance of this class, why did I write all this code anyways? And so the reason why you have abstract classes is to capture like abstract things in real life. So one good example of this is like in Java, right? You have array lists, you have other sort of like data structures, ways to hold information, right? Everything comes from the abstract class Java collections, right? Collections is an abstract idea, right? It's a way to hold a group of items. You have common methods like add, remove, find, sort, things like that. But the way that you actually do it is completely different. Like you can have an array list that you add elements and it's stored like horizontally in a list. But you can also have like trees where it branches out, and you can also have hash maps, hash tables, where it's still a collection of items, but the way you add things, the way you find things is different for each implementation. And so abstract says, okay, I'm going to define the overall structure of these things. I'm going to define that collections have these methods, and you can do these things with collections. But you're not going to actually create an collections object, right? Like it's abstract. You're not going to create a collections object. Instead, you're going to create an object of a concrete subclass. So like an array list. Array list is the child of collections. And you can create an array list, and that gives you the actual implementation for all these things that you can do with a collection. So when we talk about abstract classes, we also have to talk about abstract methods. And so, as mentioned earlier, abstract is just a modifier. You just add it in front of when you're declaring a method, and it makes the method abstract. When you have an abstract method, what it means is that it doesn't have a body, right? So here is the declaration of an abstract method. Public void, the name of the method, a method, and here it doesn't have a it doesn't take in any parameters. And then the difference is instead of a curly brace, you just have a semicolon. Because this method is abstract, so it doesn't have a body. If it doesn't have a body, you don't have curly braces, right? So this is what you have to remember. Abstract describes a method, and when abstract does that, when abstract is present, you no longer have a body. You just end it with semicolon. The idea is you're not going to write the body for this method here. You're going to write the body in whatever concrete subclass is a child of. So collection will have an abstract method add, right? It will say that anything that's a collection has to have this method add. But how you actually add it is defined by the subclass, defined by array list or by tree map or hash map. The method body isn't defined by the abstract class. And so if a class has a single abstract method, it makes the whole class abstract. So an abstract class can have one abstract method, can have 50 abstract methods, it can have a million abstract methods. But as long as one of them is abstract, it makes a whole class abstract. You can have a mix of abstract and non-abstract, right? So an abstract class doesn't have to have all abstract methods. It can have half and half or 90-10. As long as there's one, though, it makes everything abstract, the whole class abstract. And so here we see an example. Okay, a small thing. Abstract classes don't have to have abstract methods, but if there is an abstract method, then it has to be an abstract class. And so here we see an abstract class that doesn't have abstract methods. The only difference from what we've seen before is now there's this abstract. You just put the word abstract when you're defining the class, and it makes it an abstract class. As simple as that. So here, you have two methods. One that's concrete, public void my concrete method. So this one doesn't say abstract in front of it. And so you have the curly braces and you have a method body. But the second method, called my abstract method, does have this abstract modifier in front of it. And because of that, it no longer has a body like the one above it. It just has a semicolon. And so I've talked about parent classes and child classes, and we're going to start talking about that a little bit now. The idea of parent and child is the parent is like the one above it. It's generally more general, and the child is, well, a child. So it's like a descendant from the parent class. Essentially, the child will have everything that the parent has, but usually also has something more. So it's like more specific. Classic examples is like the parent class is animal, the child class is cat. So cats have everything that an animal has, but cats also have specialties, right? That's why it's a cat and not just any animal. And so when you create a subclass, a child of another class, if the parent is abstract, then the child must either implement those abstract methods or be abstract itself. Right? So if we go to our example, abstract class, my class, if we create a separate class that's a child of my class, it must either be abstract as well, or if it's not abstract, it has to implement this method. It has to have the exact same signature without the abstract keyword, and it has to have a body. It has to say this is what the method does. You can't have anything but in between. You can't be not abstract and still not implement those methods. Here it gives you a link to some like built-in classes in Java that you can see that are abstract, and just so you can see like actual example in the Java library. But we're not gonna go to there now because we just don't have the time. I'm gonna stop. Well, actually, I'll just continue a little bit. One more slide. Introduce one more new concept, and that is interfaces. So interfaces are similar to abstract classes, very similar. The only difference between interfaces and abstract classes is that interfaces are more strict. Interfaces have to have 100% abstract methods. If you have a concrete method that doesn't say abstract, that has a body, you're not an interface. Right? An abstract class can have a mix. Interfaces can only have abstract. That's the only thing you have to know at this point. Interfaces are used similarly to abstract classes. I actually kind of lied. The collections is actually an interface, I believe, not a abstract class. But the idea is the same. An interface defines like the structure, how it defines some common characteristics. And so that everything that implements that interface will share these characteristics. And that's very useful when describing, like when organizing code. Another example of why you need interfaces and abstract classes and parent and child classes is like defining maybe a paint program, right? I feel most of you probably have used Microsoft Paint or something similar. Um, just imagine you're trying to program that yourself, right? You might have a class that represents squares, right? You might have a class that represents circles and another class that represents triangles, right? But you might also have an interface that is called like drawable. And this interface defines all the methods that relate to drawing, right? Because you're doing a paint program, right? You have to like resize it, maybe you have to draw it on the screen. So the drawable interface will say, these are the methods that you need to implement. But then your square class, your triangle class, your circle class, whatever, they will all implement that interface, right? Because the way you draw a square versus the way you draw a circle is going to be different, right? A square has 4 straight edges. A circle has a single curved line, right? So the way you draw it is different, but all of them must be drawable. And so that's why you have interfaces. You create an interface so you guarantee that whatever implements it has those methods. It's like a guarantee. That's why this is important, and that's why this is used in Java. So we're running close to the end of class today. So I'm going to jump to the couple of quiz questions, and we'll go over the rest of the slides next class on Thursday. So I'm going to start with this one. This is just a sample class with a couple methods, and you just kind of have to follow along how the methods are called one after another. And so I'm gonna leave this on the screen for now, and I'm gonna create a straw poll like we've done in the past, and I'd like you guys to just put in your answer once you think you have it. Okay. The link is in the chat. This question does not involve any abstract methods or classes. This is just kind of quizzing you on how you jump around between methods in a certain class, how one thing can call another one, and how it all fits in together. So I'll give you guys, let's say 2 minutes, and then we can kind of go over it. I'm gonna go over this question now. So looks like most people put in C, and that is the correct answer. And so this is just stepping you, like you just have to step through the code. Everything starts with the main method. That's what you have to look at first. It creates a test object, which uses it to call the start method, because the start method is not static, and so it cannot be called directly from the main method. So when we call start, what does it do? Well, it creates a variable that has do, and it creates another variable that's the result of calling method, given the parameter do. And so you have to look at what this method does. Well, this one, it takes whatever you give it in. So here we gave it in do, and it adds the string good to it. So now this STRA, string A, is do good. We print it out, and we return it. So now we return to this line. We have string A that's do, string B that's do good, and we've already printed out do good. Now we print out a colon and a space, and then we print out our two variables, our do and our do good. And so our final output is do good and colon do good. This was just more of like a quiz on methods, to be honest. But I just have a couple quiz questions I want to do very quickly since we're running out of time. But this is reviewing abstract methods and interfaces. And so instead of just creating a straw poll, I'd appreciate if you guys could like just type answer choice A, B, C, or D in the chat, in the Zoom chat. And I'll just take the first answer to this. Oh, sorry. This is the quiz question, my bad. Yes, it is C. So an abstract method actually can exist. It's not dependent on an abstract class. So it's not A. An abstract method, all you have to remember, has the abstract keyword and it doesn't have a body. That's what an abstract method is. I have two more very quick questions. So that was about abstract methods. Can anyone tell me what an abstract class is? Is it A, B, C, or D? Is it one without any child classes, subclasses? Is it a class with multiple child classes? Or one that can't be instantiated? Or does it mean the same as another term? Okay, it's okay. Yeah, so actually, I'm just gonna end it now about because we're out of time. So the homework, I haven't completely decided if it's gonna be the one on the slides or something else, but I will post it to Classroom along with the slides later today. And just a reminder that class this Friday will be the final class, and it will also be adjusted to starting at 3:30 and ending at 4:30. Sorry about the adjustment. I started classes today, and I had a little bit of conflict. It didn't end until 3:15, so I'm sorry that classes started late today. But yeah, as always, check the homework and slides after and try to get it completed by Friday. If you guys have any questions, feel free to stay. I'll post the answers to the rest of the quiz questions along with the slides. So if you guys want to look at that yourself, you can. Otherwise, stay if you have questions, or you're free to go. Thank you, everyone. Thomas, do you have any questions?